Okay, so we do have a new word, kind of new word that we need to go over. First, when we're writing the equation, this comes for when we're going to get to these, quote-unquote word problems down here, which really English problems is what I like to think them as. This is math in English. We're going to translate it into math. Okay? We need to define the variable, right? Variable is just the thing we do not know. Okay, I'm gonna hammer that in over and over again because you all are gonna leave my class knowing what variable means, right? Even if you forget my name. Hook. Okay, exactly. Hook. The word. This tells us the coefficient. Okay, that's kind of our new big word for the unit. Make sure I spell that right. I before E except after C. So it's COEFFICEINT. Big word. Okay? I want you to really focus on the first two letters of that word. Co. C-O. Can anyone think of any other word that starts with the co?
Cooperative.
Okay, cool. That's actually good. Cooperative. So an operative would be someone working, and a cooperative would be, right? If you're cooperative, you're working with someone, right? What about a co-worker? Someone's like cow. Maybe. Okay. Well, okay, I did say so. Yeah. Okay, cow work. But for what we're trying to do, co-worker, right? That implies you have a worker and someone you're working with. Any other co-words like that?
Company.
Not really. I also thought co-pilot. What's a co-pilot?
Somebody, a substitute pilot.
Yeah, right? They're with the pilot. Okay, so the coefficient is going to be the number that's attached to the variable. It's always going to be with the letter. Okay, so a coefficient is always going to be with, right? Coefficient is always going to be with the variable. So what number here is the coefficient? 4. Coefficient. All right. So really, we've kind of mapped out our whole equation now. We've got a word for every part of this, right? Our numbers that don't have anything attached to them. Do we remember what those are called? Also starts with a C. Constant. Yeah, very good. Constant. Very good, Luna. So constant. That would be. I'm going to draw. There's going to be a lot of arrows going on. So we have constants. We have the coefficient. And then finally we have, what is A? The variable. Yeah. Great, Emma. The variable. Variable. Okay, so coefficient, again, that's always going to be with the letter, with the variable. Constant, they're all lonely, they're by themselves. Okay, so when we're using this vocabulary, remember those tricks to kind of help you remember what's what. All right? Coefficient. So there's kind of lists, like we had on Wednesday, there's lists of words that mean addition, there's lists of words that mean multiplication, division, subtraction. I don't want you to memorize anything like that. This is, the way you're going to learn this is practicing, right? The way you're going to learn technique is by swinging the bat 1,000 times, doing a bunch of word problems. There's no other way to do it. There's no hacks, right? I'll teach you the best technique I can, but you're going to have to put the hard work in. So you're going to see words like every, each, per. That's going to, what is it? That's going to clue you in that you're at your coefficient. And if you're at your coefficient, guess what you're at? What's your coefficient always with? What's it always attached to? The coefficient is always with the variable, correct, right? So that's really helpful to know. If you see when you're reading a problem and it says every, each, per, so like it costs $20 per ride, right? The per ride, $20 per ride, that's going to be 20 times the number of rides you're going to do, right? So if you want to know, okay, how much am I paying, and it's $20 per ride, it's 20 times, we'll see that. Constants, when we're doing our word problems, again, those are just numbers by themselves. Okay, they don't have variables attached to them. All right. Starting with just solving the two-step equations, it's the same exact process as solving one step. So remember day before, sorry, I preached for a good 10 minutes probably total. I'm teaching you technique because right now, one-step equation, that's like me holding the baseball right in front of you and saying, okay, swing and try to hit the ball. All right. What we did with technique is you learned how to hold it right? You learned how the proper format of it. Okay, because now when you get a two-step, that's like me tossing the ball to you. Okay, and if you were practicing swinging it the same way, the ball is going to be in the same spot, right? You're still going to hit it. Okay, so that's why the technique is so important. Next week, when we hit multi-step equations, right, meaning more than two-step, that's going to get a little bit more challenging. Technique's the exact same way. All right, finding those opposite operations, doing the same thing on both sides, that takes you anywhere you need to go with this, okay? Combine like terms, collect variables to one side. Again, our letters, our variables, we need those on one side of the equation. So first we split it so we can clearly see there's two sides to this equation, right? Collect constants on the opposite side. So we want, basically that's saying we want it to look like at the very end we want x, we want our letter, our variable equals to our number. Whatever the number is going to be, right? That pound sign, that just means numbers. Okay. Isolate the variable, that was just a key step. And what do we say isolate means?
Like, make it by itself.
Make it by itself. Get it alone, right? Wilton, you feeling isolated back there? Wilton, wake up, man. Isolate the variable. Okay, do you get that down? Maybe? Yes? Okay, sit up, please. My first period, I have to have a kid who stands up during class sometimes. Not as a punishment, a little bit, but it helps them stay awake. Okay, so you don't want to do that. Isolate the variable, and again, when we're doing that, we're going to use multiplication, so you can do parentheses or little x or dot, or division for that final isolation step. Okay, it's going to be our coefficient. We want to. That's like when we're separating, right? It's sad, right? Because the coefficient really, that's the partner of the variable. We're going to separate them. We're going to isolate the variable from them. We're breaking them up. Okay, so our last step, our breakup step. Like if we want that 4a to just be, we want a by itself, we're going to have to divide there. All right. If we have division happening, like this 2, this coefficient, we're going to have to multiply. Okay, so isolating it, making that coefficient go away. And of course, checking our work. All right. Like I said, if you want more room, even when you're doing the notes, do what you can here. If you're checking it, you can check it on a separate sheet of paper. I'm sorry about the spacing today. 5 equals 4a minus 7. Find my variable. There it is. I need to undo what's happening to it, okay? I gave you all these sheets. This is actually from a different teacher, the way she kind of teaches it, which works well. I always say find your variable and point to it. Right? So I say find your x. She says cover up the term with the variable. So she says cover up your coefficient. All right, you find it, you're pointing to it there too. Then get rid of the constant beside the variable term. Okay, so we have our variable. The first thing we want to get rid of, right, because our goal is we want to kind of whittle this thing down. You know what whittling is?
Like break it down.
Have you ever whittled wood before?
Whittle like small.
Like you get a pocket knife and you're cutting like a block of wood or something.
Yeah,
Yeah, whittling. Okay. So you making it smaller, whittling it down. And so we want to just have x here. So what's happening to x? Well, it's being multiplied by 2, and then it's being added to by 3. Okay, so to whittle that down, we got to start on the outside of the whatever we're making, right? Outside of the thing to get closer. So we're starting with this 3 here, right? So we're going to get rid of this positive 3 somehow. Okay, how do we get a plus 3 to go to 0? What should we do? What's the opposite of addition? Subtraction, right? So if you have $3, what's the best way to get $0? Spend $3, right? Yeah, okay, subtract 3. Okay, so that would be the first step there. After we subtract 3 from both sides, how would we get rid of this 2? It's 2 times x. How do we get rid of multiplication? Division, yeah, divide by 2. Okay, so we're going to glue this in. This is just a good kind of steps to get you through if you get stuck. Here we have minus 7. I'm going to zoom back in. We have minus 7. To get that to 0, right? Because here's our variable, and we're gonna whittle in to get it just there. We have minus 7. We're gonna add 7. But if I do it on this side, I have to do it on this side for sure. Always, everything. Plus 7 plus 7. Okay? Notice, I am adding 7 to this side of the equation. I'm not adding 7 to 4a and adding 7 to minus 7, right? That'd be like adding 7 twice. I'm adding it to this side. So really, that's the same thing as doing 5 plus 7 equals 4a minus 7 plus 7. If we wanted to write it out, this is what we're doing. We're adding 7 and adding 7. Okay, and you can easily see when it's written out in a line like this, right, just like if we were combining like terms, this minus 7 plus 7, well, those cancel each other out. They're a 0 pair, right? So I don't want to see people, and I have seen this a few times even today, was they tried to do, okay, what is 4a plus 7? Is it 11a? Can I do that? No, you can't add apples and oranges, right? Right, it's 4a plus minus 7 plus 7. Those cancel, and you're done with it. Okay, there's only one 7 there, right? Over here, 5 plus 7, 12.
Divide by 4 is 3.
Bring down your 4a, and then we have multiplication. We're going to undo multiplication with division. Cross it out. 12 divided by 4 is 3. So we have 3 equals our a. All right. To remind you how to do the check steps, okay? People have been telling me, I keep forgetting how to check it. Write it down exactly how it is. 5 equals 4. But instead of your variable, you're checking what it is. So you just write parentheses. Minus 7. Okay, then you can go look. Well, I think it's 3. 4 times 3 is 12. What is 12 minus 7 equal to? Is it equal to 5? It is. Right? This is the piece, this is what I look for, like whenever you're solving it. I want you to box this. Show me your answer. Okay? Show me your work. On the quiz, I had a lot of people who just kind of, they figured it out because, right, those one-step equations, they're not tough to figure out. If I say, 2 plus what number is 4, you can get 2 without doing any of this, right? The people who showed me this work, I knew they were the ones who actually know how to solve an equation. Okay, what I'm looking for is this, right? Let's go over here. All right. The curveball aspect of this is that now we have 3 minus 8c. It's a little blurry. 3 minus 8c, okay? Is this a positive 3 or a negative 3? A positive 3. So let's think about it in those terms. How do we want that positive 3? What's the fastest way to get a positive 3 to 0? Right, subtract it, right? So still, we want this positive 3 to go away first. So we're gonna subtract 3. Just because it's 3 minus 8c doesn't mean we're adding, right? We could add a negative 3. That would be, right? If we add a negative 3, is that the same as subtracting? Yeah. Yeah, so if you want to do plus negative 3, that's a perfectly good thing to do. All right, just make sure you do it right on both sides. You could also just add 3. I mean, subtract 3 rather. Sorry. Yeah. So adding negative, right? Adding debt to yourself is like, you're getting negative money. Okay. What is 3 plus negative 3?
0.
0. Good. Yeah. Wilton's on it. It's always going to be either 0 or it cancels out and it's 1. That's the reason we do these steps, is because we're making things disappear, right? 35 plus negative 3, or 35 minus 3, 32. Okay? Those integers, I heard it. If that trips you up, calculator's your friend this year. Okay? Work with it. Now, the important part is that this minus sign, it doesn't just get to go away. We have 3 minus 8c. We got rid of the 3. That minus sign becomes a negative sign. Okay? Because really what we have now, if we subtracted 3 from that, we would have 0 minus 8c. Right? And because we don't write stuff like that, like we have a 0, we never write it. 0 minus 8c is equal to negative 8c. All right? So that minus sign comes down with it. That's why I said it was so important whenever we were combining expressions that you circled or starred or made a heart around. I had some of those. I think they were just trying to annoy me. But you included the operation symbol because that stays with the number. So now we have negative 8c equals 32. How are we going to undo that multiplication? Negative 8, negative 8. C is equal to negative 4. Any questions? Checking my work. 3 minus minus 32 equals 35. It's good practice whenever you see that double minus thing going on. Make your little dude. Circle them, put a plus sign.
Wait, why is there 2 minus?
8 times negative 4 is negative 32. So it's 3 minus negative 32. Yeah, no, it's a good question. Keeping up with negatives is probably half the battle when you're solving equations sometimes. All right, try this one on your own. I'm gonna give you a minute. Just have a variable, right? We need to start whittling away what's happening to it, starting on the outside, starting way out here. Negative 3.7. All right, let's make our two sides. How do we make a negative 3.7 go to 0, right? If you owe me $3.70, how much do you have to pay me to clear your debt to owe me $0? $3.70, right? Plus 3.7. Plus 3.7. You do it one time on this side and one time on this side, right? You don't do it twice. You don't do it here and here and here. You do it once here and once here. So the 3.7, that cancels out. I bring down my minus, now it's a negative sign, negative 6.4x. Bring down my equal sign because this is an equation. And when I add that together, it's 51.2. Okay? Multiplication's happening, so I'm undoing it with division. Don't have to think about what to do in terms of the number because I just do whatever's in front of x. So divide by negative 6.4. 51.2 divided by negative 6.4. I know some of y'all know it, but I want to type this in the calculator just for sake of the video. Let's do our negative symbol is at the bottom of our calculator, right? So 51.2 divided by negative 6.4, negative 8. Any questions? Great. Y'all are doing really well.
Can we do the one below it?
The one below it? Yeah, why not? Oh, do it on your own or do it together?
No, together.
Together? All right, let's do this one together, and then I'm going to have you do one with division on your own. So this right, fraction means division. So we have 15 minus w divided by 4 equals 28. Okay, take care of the constant first. So I'm going to split it. I have a positive 15. How do I make $15 go away? How much do I spend? 15. Do it quick.
Oh, I thought we were supposed to get rid of the division thing first.
No, always want to get rid of the constants first.
I know that.
The constant, so the 15, you want to get rid of that first. Okay. Coefficient, that's the last thing. Coefficient is really, really strongly attached to the variable. Okay, that's like, I mean, they're together. They think they're together for life. We're about to break them up, though, right? But you got to get rid of this extra stuff first. You got to get them in a room by themselves, and then the breakup happens. Okay. W4 that needs to take place after you get rid of the constants. All right, I'm gonna stop before I get weird with these analogies. What's up, Daniel?
Bro, you sound like Miss Mullins downstairs science teacher. He says, well, don't put anything on paper, like your boyfriend's name or girlfriend's name. And then in high school, they'll be fine, breaking up. Take it down.
Tends to happen, doesn't it? All right. But what do we know? We're just teachers. 15 minus w over 4 equals 28. So we're subtracting the 15, goes away. We're left with, again, bringing down that minus sign. We can't get rid of that. Minus, so negative now, negative w over 4 equals, what is 28 minus 15? Somebody help me out. 13, thank you. Okay. We're dividing now. How are we going to undo division? Multiplication. Okay. So it's negative w divided by 4. If I multiply that by a negative number, will it turn it positive? A negative times a negative is positive, right? So instead of just multiplying it by 4, I'm going to multiply it by negative 4. And if I do it on the left side, got to do it on the right side, always. All right, so those cancel. The negative sign as well, right? We're left with w. W equals, what is that going to be, guys? 13 divided by negative 4. I got negative 3.25. 13. Oh, did I say divided? I did say divided. 52. Thank you, Mr. Land. Negative 52. Negative 52. I told you I gotta watch me.
It's okay.
I know what I'm doing sometimes. Hopefully I'm not teaching y'all wrong. Just kidding. Not teaching y'all wrong. I've been doing this for a few years, so. W equals negative 52. We got negative, I'm going to put my parentheses, 15 minus, put my parentheses over 4 equals 28. And then to finish the puzzle, I'm saying it goes right here. Right? Negative 52 divided by 4, that's going to be negative 13. So we have 15 minus negative 13 equals 28. That minus minus is a plus, and that becomes 28. All right. Do this one. And I'm going to come around and see how you did. All right. A divided by 2 minus 7 equals 9. Again, what's our coefficient? What's attached to our variable? the 2, right? Technically, it's like, you can even think of it as 1/2 times a if you wanted, but it's a divided by 2, so that 2. We have a constant, minus 7. We want that to go away first, right? Constants get out of there, okay? That way we can focus on this coefficient that we need to take off. All right, so we split it, right? Minus 7, that needs to get out of the way. Go in the other room. We're going to add 7. If we add it on one side, we have to add it on both. Everyone I saw, save someone who just read it incorrectly, got that part right. That's great, okay? So add 7 on both sides. Carry down a divided by 2. And over here we have 16. Yeah. Okay, so now we have one more step left. A divided by 2 equals 16. How do we undo division? Multiplication. So I'm going to multiply times 2 and times 2. The 2's cancel, all right? And I want to show you what we're doing here, okay? Because I think I'm just saying they cancel, and some of y'all are taking my word for it, which is good. You should take my word for it. But let me show you what actually is happening here. We have 2 times a divided by 2. I'm going to write it up here. 2. This is how we have it. 2 times a divided by 2. And we're saying, okay, those cancel, right? Really, 2 is the same thing as 2 over 1, right? Same number? Yeah. Okay, so we're really doing 2 over 1 times a over 2. And if you multiply that out, some of y'all, if you remember how to, when you're cross-multiplying fractions, cross-canceling, you can see how those cancel now, right? And then we're left with a over 1. Y'all remember how to do that, multiplying fractions? Or you can multiply it all the way out. 2a over 1 times 2 is 2. That's what you're left with. Now look, that's a lot easier to see. How many times does 2 go into 2? Well, 1. So really, that's what we're doing when we're saying multiplication undoes division. Okay? Since we don't want to write all that every problem, right, we start seeing that, oh, if I'm multiplying, whatever I'm multiplying by can cancel whatever is in the denominator. Okay, but if you have this written down, that'll kind of remind you, bless you, what the process there actually is going on. Okay, or just take Mr. Land's word for it, 'cause why not? A equals 16 times 2 is 32. Okay, questions on that? Good. Are y'all feeling a little more confident or less confident? Is what I'm doing hurting? A little bit.
Just so if we're doing our work, like if we're trying to show our work, we could do that.
Yeah, show it on the paper.
Paper.
Yeah. For the stuff you turn in. For stuff you turn in, yes. Yeah. Okay. Last one we're going to do together. That is break time. So Thursday. All right. So solving this last one. Same method, but there's a little trick to this one. Okay, that may have stumped a few of you. All right. This is negative 1/2 times x. Negative 1/2 times x minus 7 equals 11. Okay? So we undo multiplication with what? Daniel? We undo multiplication with division. So we could just divide negative 1/2 by negative 1/2. That's a lot of division going on, right? Because fractions are division, so we're going to divide by division. Okay? Really what we're doing when we're dividing by division is, it's kind of like when you subtract by a negative, you're adding. When you divide by division, it's kind of like multiplying. Yes, Wilton?
So you can go to negative 0.5.
Uh-huh.
So is that 1?
Yeah, so negative 0.5. Negative 0.5. That's what it would be. But let's leave it as a fraction right now. But that's good. Good point, right? If you have your calculator and you want to look at it as a decimal, Wilton's got a really good method too. Okay, there's a couple different ways to skin this cat. Sorry, that was a little graphic. Negative 1/2 x minus 7. So if we divide by, I'm going to do this in pencil so I can erase. we divide this side, or, well, first we need to add. Let's get that out of the way. What am I doing? Add 7, right? That constant needs to get out of the room. Plus, so now we have negative 1/2 times x, negative 1/2 x equals 18. All right. Now for the breakup, right? How do we get this coefficient of 1/2 to go away? So we can just look at our variable. So I said we could divide, do a division sign, and do divided by negative 1/2. All right, and anything divided by itself is always 1. Well, 1, yeah. Okay, so then it would go away, and then 18 divided by negative 1/2. Right, we could do it that way, and you know what's great about doing it that way is we still have calculators, and do y'all remember how to put fractions in the calculator?
Yes.
You can use parentheses, or you can actually make it look like a fraction. 18 divided by alpha y equals, enter, look at that. Nice little fraction thing. I forgot my negative sign, so I'm going to back up and put that there. Divided by negative 1/2. Our answer is going to be negative 36, okay? If you want to do it this way, perfectly fine, okay? You can do it this way. Your answer is negative 36. You got it right. You could also, I'm erasing the pencil now to try a different method. Since fractions are already kind of division, if I multiply to get rid of this division going on, I can multiply it by the reciprocal, which is just the same fraction but flipped. Negative 2 over 1. That's the reciprocal fraction to 1/2. It's just the fraction, but the numbers flip. Okay, and then watch. Negative 2 times negative 1 is 2. 1 times 2 is 2. So really it's 2 over 2 times x. And what does 2 over 2 equal to? 1. Exactly. Okay? So I'm left with 1x over here. And on this side, 18 times negative 2 is negative 32 over 1, or negative 32. Okay? So two ways to go there. Knowing the reciprocal method, can you all say that word, reciprocal? Reciprocal. Knowing that method is helpful because sometimes you'll have kind of ugly looking fractions. I mean, let's face it, we don't like to look at fractions. And it's a good way to get rid of them. Okay? X equals negative 32, and then plugging that back in, of course, y'all know how to do that. And solving. Okay, now onto the good stuff. We have English problems, word problems. If I say English problems, it makes me think of English class, and that it's not fun. So maybe I would like English class if y'all have to diagram sentences. That always just like takes the life out of it. Where you have like a sentence diagram. I don't remember how to do it probably, but you have like the dog went to the park or something, and then you have to make these like.
We can't see it.
Yeah, that's what we have to do.
You have to do this,
Oh, no.
right? And then you have to write all your adjectives, and you got some like stuff going on out here. And, oh man, that was the worst. Okay, none of that. What we are going to do though is we're going to annotate. Does anyone remember what annotating means? Anna, smartest student. Do you remember what annotating means? So when I annotate a book, like I showed y'all,
You highlight.
you highlight, right? You underline. So you highlight, you underline. There's some highlighter, right? You highlight. If you have something you want to write, you write a note to yourself, okay? When we're doing our word problems,
I make you want to read it again.
having a highlighter is really helpful, okay? If I see, I'll let you in on something. If I see highlighting and annotating on a word problem on a test, all right, even if it's completely wrong, I always give points. Always. Not full credit, obviously, but I give a good bit of points. Okay, so if you want to take your test with a, you can use a highlighter on it, but underlining, circling stuff in your word problems, that's a sure way to get some points on your test.
Will you give us extra points if we do it on that?
You buy 3 books that each cost the same amount and a magazine for $55.99. The magazine costs $1.99. How much did each book cost? Okay. If I just read something like that and then they say, okay, write an equation, my stomach starts to get a little tight, and I'm like, I don't want to do this, and breathing becomes difficult, right? Pull out a highlighter. I'm going to show you how easy this is. All right. If you don't have a highlighter, your pencil's fine. You can underline. It'll show up better though. So you buy 3 books. I'm going to highlight that. 3 is a number, so I'm guessing it's important. We're doing math, right? Each costs the same amount. Okay? And a magazine. And is important, right? What does and mean in math? Adding, yeah. I think it means adding. So I'm going to put a little plus right there. A magazine, all 4... $55.99. Does that sound like a totaling all 4? Like if we could put all equals $55.99, so maybe that's an equal sign right there. The magazine cost $1.99. How much did each book cost? How much did each book cost? That's the question, right? So book cost. My variable, my unknown, right? How much did each book cost, guys? I don't know, right? I'm going to put B for book. Okay. Over here, how many books did I buy?
3. 4.
I bought 3 books. So let's see what we got now. Just looking at our annotating. 3B, I'm going to write it down as we read. 3B plus A magazine. How much does A magazine cost? $1.99. All 4 equals $55.99. How about that? That's a little less intimidating now, right? We've done a few of these. Okay? Use this. This helps. Okay? It's not additional work. Really, like when you're doing it, that's your brain will process that so much easier. Okay, especially if reading's not your favorite. Or if, lots of words kind of get jumbled in your head sometimes. It does for me. Highlight, underline, circle. If you highlight the whole passage, that would kind of be self-defeating, right? It's like saying everyone's special.
I am kind of special.
Just kidding. Y'all are all special. What am I talking about?
What kind of special? Like the wrong special or the good special?
All right.
More to that one.
We have our equation now. 3B plus 199 equals 55.99. So let's start with, we want that B by itself, right, with its coefficient, so we can break them up. Let's get rid of this 199. He's just a tag along. He's a third wheel. You all know those people. 199. 199. And by those people, I myself have been a third wheel. Third wheel's great. Okay, you don't have to deal with all the whatever. Left with our 3B. 3B equals, and I'm running out of room here. Hopefully you're smarter than me and left yourself some. $55.99 minus $1.99 is going to be $54. Right? Am I crazy? No, 54. Okay. How do we undo this division? How do we separate these guys, Wilton? Divide by 3. Awesome, dude.
Good job, Wilson.
Divide by 3. All right. We're left with B equals 54 divided by 3. 18. How much does each book cost, guys? $18. Yes, sir. Ma'am. And then to check it, oh, y'all know how to check it. You plug in your number. Questions on that? All right. I'm going to do this one here, and then I want you all to do this on your own. So let's do Candy Crush. Luckily, I avoided it. to get rid of ads on Candy Crush, Miss Blackshear paid a one-time fee. That sounds important. One-time fee of $275. She also bought. Okay, so she bought. She's getting something else. She's adding something. Extra lives on sale for 10 cents each. So lives cost 10 cents each. If she spent $5.05, how many extra lives did she buy? Okay, so we want to know how many lives did she buy, right? If you ever have a question, if you ever have an unknown, what do you think that's going to be? Is that going to be your variable?
Yeah.
Oh, yeah. So your variable, I'm going to do X for lives just because the letter L gets a little confusing. Kind of looks like a 1. So I'm going to say X is number of lives. That's my variable. All right, coming back up here, I have that one-time fee. I might just circle my number. She also bought, right? If she's getting additional of something, what symbol do you think we're going to use? Addition? Yeah, great. So I'm going to put a plus sign there. Extra lives, yeah, she's right there. Extra lives on sale for 10 cents each. So how much does each life cost? So our coefficient is 10 cents, so 0.10, if you want to put the 0. And then our times L, times each life, times X. And she spent how much? She equals, her total is $5.05. All right, so just using that annotating, we're going to come down here. $2.75. We have a plus. Lives are 10 cents plus however many the lives cost. What'd you say?
$2.03.
$2.03 for what? $5.05. What are you talking about?
You subtract 5 and 2.
Let's see what we got going on. All right, we want get rid of the constant, right? So we can separate the coefficient. So get rid of the constant. What are we going to do first? Subtract 275 from both sides. 0.10x equals, what is that? 2 what?
2.30.
How much is that in money? And 30 cents, right? 30 cents, because 3 is in the tenths place. So $2.30. Remember, cent means 100, right? So cents is out of 100. So really, we're saying that her lives, she spent $2.30 on lives, right? If we were just following what we did, we said she spent this much total. Okay, she spent this much just on lives. 0.10 times however many lives, she spent this much total on lives. So to get how much she spent on one life, I know, right? 23 lives. 2.3 divided by 0.1 is 23. Questions? All right. I want y'all to do this one on your own, and then I'm going to check it, and then we'll be done with our notes. All right. Coming through with my highlighter. The mechanic charged him $130 for parts, and is plus, right? And $40 per hour. Okay. Anytime I see that word per, right? That was my hint. I know I'm dealing with a rate here, right? It's how many hours? Okay, so H, it's 40 times, right? I'm paying $40 per hour. If you take your car to the mechanic, you always want to know how long is the job going to take, because they charge sometimes like $70 an hour. Okay, so yeah, $40 per hour for labor. If chemo, no, that sounds like cancer treatment. If chemo's bill totaled $270, how many hours of labor was required? So $270 and total is going to be equal, right? So we come through, we say, okay, variable is H for hours. That's what I want to figure out. How many hours? 130 plus, there's my plus sign, 40 40 per hour, and that's going to total to 270. All right. I look over here. I want to separate my 40 and my h. I want to get my coefficient gone. Right? Gone is not a word. But first I got to take care of that constant. Minus 130, minus 130. 40h equals 140 divided by 40 divided by 40. H equals, what is that, guys? 3.5? So how many hours, guys? How many hours were they working? Which is how many hours, right? We don't say 3.5 when we ask how many hours. How would you convert that to hours?
3.5.
3.5, right? 3 hours and 30 minutes. That's what I was looking for. Good. Okay. Fold it. Glue it.
I had to get me some of that